doing problem 12-28 from the fundamentals of chapter 12. Alright, and like I mentioned in the previous video, we're basically doing problems where we need to find the tangential velocity, acceleration, sorry, and the normal velocity, right? And that's the one term that they introduced in that section of the book, which is going to be your velocity divided by your velocity squared divided by the radius of curvature. And again, we're taking turns in this problem, right? So we need to find what the acceleration in the normal direction is going to be, right? This one's going to be just your dv dt, right? Just your regular acceleration. So here the car is traveling along the road with a speed of v equals 2 seconds, all right? Or sorry, v equals 2s, right? Where s is in meters. Determine the magnitude of its acceleration when s equals 10. Okay, so after, when s equals 10 over here, what is its velocity? What's its acceleration in the tangential direction? And what's its acceleration in the normal direction, right? And we're given all the tools here, all right? So v, or actually, since we want to find the acceleration in the tangential direction, right? They're trying to throw us a curveball here by giving us the velocity in terms of space or spatial direction, right? Not in terms of time. So since we're already used to doing the chain rule, right, we can just say dv ds ds dt, okay, which then becomes, what's the first derivative of the velocity with respect to space, or s? That's going to be 2, right? And then what is ds dt? Well, that's just the velocity. Okay, so that'll be 2s. Me 2s. Okay, and then we get 4s. All right. One thing we can do is, at 10 meters, where is it? 10 meters, we get that the velocity is 20 meters per second. All right, because we'll need that for the normal component of the acceleration. Okay, and then my acceleration in the tangential direction, right, at 10 seconds, so at 10 seconds, that's going to be 4 times 10, sorry, not 10 seconds, there's so many s's here, at 10 meters, when s equals 10 meters, right, so 4 times s, we're going to get 40 meters per second squared. Okay, alright, you know what I mean. Alright, so yeah, 40 meters per second squared for the tangential acceleration. We have our velocity at that moment of time when you're crossing that 10 meter mark. And now we can just easily find the normal component of acceleration, which is going to be v squared over rho, which is 50. I love when problems just give you rho and you don't have to look for it, but we're going to have to look for it pretty soon. So yeah, so v squared, so that's 400, right? Just plug that in there, divided by 50, cross out some, and then this is 8 meters per second squared. Okay, and let's see, what else do we need to do here? So we have 40, we have we have 8, so then just get the normal. So now we just want to calculate the magnitude of the acceleration, right? So it's going to be my AT squared, which is 40 squared, right, plus the normal component of the acceleration, which is 8 squared, right? Plug that into your magical calculator, right? And we should get 40.8 meters per second squared. Okay, and that's it. As you can see, these problems are pretty simple, right? The only times that it's going to get a little longer is when we have to solve for, if they don't give us, they just say row, right? And we need to calculate that. We'll need to do some algebra, some calculus for that. But I think we'll get into it in the next few problems. Alright guys, hope this video helped with formatting your problems, identifying what you need to do, and then most specifically how to use skills that we previously learned, such as the chain rule, into finding the velocity, or the acceleration. Alright, if you have questions, comments, concerns, drop them down below, and don't forget to like and follow. Thanks guys, see you in the next video.